Welcome back guys sa ating Calculus-Based Physics Midterm Part 2 na tayo. No? Continuation lang to nung Part 1 natin, which is yung last topic natin, constant acceleration. No? So, yung diniscuss natin no, sa Part 1 ay constant acceleration ng one dimension. No? For example, si x lang. How about kung 3 dimension tayo? Yan. Ito yung didiscussing natin. Unang didiscussing natin para sa ating part 2, 3 dimensions. No? So the same din. No? For x, we have the following formula. Yan. So, pag sinabi kasing 3 dimension, ay tatlo yung line niya. No? Para maging, bawa, ito, 2-dimension na box. Di ba? Yan. Ay, teka. 2-dimension na box. Pag sinabing 2-dimension na box, ano itsura? Ganito. Yan, di ba? So, meron lang siyang y, meron siyang x, no? Vertical line, horizontal line. Pag sinabi mong 3 dimension, ano na siya? Meron na siyang third line, si Z. Yan, no? So, paano naging third line? Kasi pag nilagyan mo siya dito, yung 2 dimension mo, nilagyan yung third line, magkakaroon na siya ng solid, no? Na solid na perspective, no? So, pag gusto maging parang tunay na box to, ayan, lagyan mo lang siya ng shading, no? So, yung third line na yon, yung CZ yon, ZZ. Ito na nakalagay sa formula. Okay? So, yung ibig sabihin ng dimension, no? 3 dimension. Yan. So, yung formula natin the same for the 3 dimensions, no? X, Y, and Z, no? So, dx times t over dt, dy, dz, no? Yan ay v, velocity. So, pag meron tayong constant acceleration, syempre, may acceleration ka, meron kang velocity, no? Pero constant nga lang, no? Hindi nagbabago. So, ito yung side ng acceleration, no? So, meron din siyang x, y, z. Okay? At remember, yung formula natin, merong dv, which is yung change in velocity na, no? Okay? So, dv x times t, ito naman y, ito naman z. Okay, very simple, no? So, paano natin siya pag-iisahin, no? Paano i-combine? So, repeat. For each pair of equations, the steps that led to the constant acceleration formulas for motion in the x direction. So, the same daw, i-repeat lang natin yung formula ng ating constant acceleration, no? So, from the acceleration formula, ito yon, no? Velocity and acceleration formula, we derive the constant acceleration formula, which is merong 1/2, no? Ayan. So, xt equals, yan, meron na tayong 1/2 ngayon, no? And replacing that, yan, ito yung sa velocity side, no? So, we will have the final formula, no? As a single formula. Meron siyang arrow doon. Okay? And that's how you combine, no? The formula for the 3 dimensions. Okay, so ang use daw niyan, the formulas were important historically, no? For they were the first to allow the accurate prediction of motion, especially nung cannonballs. Noong panahon kasi, unang panahon ay mga cannonballs pa lang ginagamit sa sa giyera, no? So napakahalaga sa kanila noon na ma-compute yung trajectory, no, ng isang cannonball. Yun yung practical use nun dati. Okay? We go now with differentiation. No? We saw that the basic idea was the integration of some curve or function of t, no, or f of t. So the curve or the ft is equal to or was equal to the area under that curve. So it is an easy concept. But the problem arose when we actually tried to find the formulas for the areas under various curves, no? Meron kasing curve na rectangular, no? Which is, na-derive natin, ft is equal to constant, and the triangular curve, no? Or area, which is ft equals 80. It was perhaps a surprise that the area under the simple curve 1 over t should turn out to be a logarithm. Yan yung diniscuss natin before, no? Yung, yung may negative value cn, no? Which is, it turns out, logarithm siya. Yung xn and yx and then yung ex, no? So, for differentiation, the basic idea of the process is given by the formula. Yan, yung ating differentiation formula. No? It is a shorthand notation for a whole series of steps which we introduced through the use of the stove photograph. So, based from our derivation, ito yung final formula ng differentiation na nakuha natin. Okay? Ngayon, ay kukunin naman natin yung derivative, no, of a curve uh, using, no, a series expansions or binomial expansion. So ang binomial expansion is a type of series expansions, no? At ang formula ng binomial expansion, which is malalaman natin mamaya ang kanyang use, no, ay ito, no? So meron siyang uh, format, no, na susundin natin para ma-derive natin yung series of differentiation formula and integral formula for varied format ng function. For example, when a is a number much smaller than 1, okay, yung a na yan is a graphic representation of it's a Greek, no? It is a Greek representation of letter A, no? Alpha. So we can neglect now if a is we can neglect now a squared compared to a dahil if a is equal to 0.01 then a2 or a squared is equal to 0.0001 with the result that we can accurately approximate which is x plus a to the n power by saan yung galing dito sa ating binomial expansion. Yung first part niya, no? So, 87 gives us the approximation formula. Okay? Yan yung ating gagamitin, no? To derive the differentiation and integration ng some varied form of functions. For example, if we give x a value of 5, n equals 7, and the alpha equals 0.01, we can calculate, no? Using calculator, this value, 79225. Okay, so paano gagawin? Enter mo raw yung value, 5.01. Press mo yung yx, then press mo yung 7, then press the equal button, and this value will appear, no? So, compared dito sa right side, gagawin nating manual, no? Para malaman natin na tama ba yung ating formula na to. So, calculator versus manual, no? Itong right side. O kaya ginamit natin yung ating equal sign ay estimated to be equal to, no? Hindi natin to ginamit kasi hindi pa natin alam kung magkapareho sila ng result. So, nakuha na natin to, which is ito yon 79225. Ito naman yung kukunin natin manually, no? Hindi gamit ang calculator. So, 5 to the 10th power plus 7 times 0.01, which is yun yung alpha. X is 5 to the 6th power. Okay, yun yung x to the n minus 1. So, we have 78125 for the 5. It's the 7th root of 5. I mean the square of 7, the 7th square of 5 is equal to 78125, no? So, for this side, ito yon, we have 7 times 0.01 times 2, times 5 to the 6th power will give us 1093.75, and combining them will give us 79218.75. If we compare, no, yung calculator 79218 for the left side, sa right side, we have 79225. So, see, hindi siya exact, pero pakunti lang yung kanilang difference, no? The smaller alpha value is compared to 1, then the better the approximation. We go now with the derivative of the function xn. Using the approximation formula, we will find out the derivative for this function. No? So, from the definition of the derivative, we have, ito, from the function of the formula of the derivative, ito yung ating gagamitin. No? Since since change of x is to become infinitesimally small, we can use our approximation formula for a plus alpha to the n power. No? So, we get the following derivation. So, wini-replace lang natin si change of x kay alpha, and then we will have the following derived formula. Ito, no? After, after cancellation, no? For example, anong kinakancel natin? Una muna, ni-replace natin, no? Ito, si alpha. Okay? Ni-replace natin ng change. Yan, no? Change of x. Change in x. Then x to the n power. So we have x to the n power. So ano yung mga cancel out? Cancel out. Next. Ano pa? Wala na. So we arrive at this general formula for the derivative of function of xn. In our discussion of integration, we saw that the constant could come outside the integral. Paano naman daw kung may constant? So, insert lang natin sa unahan. Ayan, si A, no? Sa unahan ni f of x kasi siya ay constant. Yun yung form ng function na to na merong a or constant. Simple lang, i-insert mo lang daw yung a dun sa formula. So ito, magkakaroon ng axn, no? Axn to the an minus 1 power. Next, we have the chain rule. There is a simple trick called the chain rule, no? So, kung wala daw chain rule kasi, yung derivation ng ating mga various function, no? Various form of function, medyo mahaba katulad nito, no? Ito, dito ginamitan ng chain rule. Pero kung gagamitan mo ng chain rule using this formula, mapapaiksi niya mapapashorten niya yung kanyang procedure, no? So for example, hanapin natin yung variation. Kanina kasi is x to the n power, no? Yung variety of function na sinasabi, paano naman daw kung merong x squared? Na merong squared na yung x. So using the formula of the chain rule, yan, we will arrive at the following, no? Yan. So cancel, x, and d. We have 2x, 2n minus 1. So paano nagkaroon ng minus 1 dito? Okay, di ba yung x divided by x, may power si 2n doon. So ano sabi natin kapag magdi-divide ng like terms, yung exponent mina-minus natin, di ba? So, yung x sa baba, mayroong exponent na 1 yon, no? So, dividing them will give us x to the 2n minus 1 power. Si n naman, si 2n, paano nagkaroon ng 2n dito? Using or following the formula for from the approximation formula, no? Yung ating binomial expansion. Di ba? Makikita mo si n ay power. May n din siya doon. So kung anong power ni n, ibig sabihin, kung anong value ni n, nakalagay din siya sa unahan ng ating alpha or ni x, no? So in this example, 2 ang kanyang power. So 2n ang kanyang power. So ilalagay natin sa unahan si 2n. Kaya meron siyang 2n doon. Okay? Ito naman yung steps kung hindi daw natin alam si chain rule. Kung hindi natin gagamitin si formula ng chain rule. So, medyo mahaba yung procedure, no? Yan. Magsisimula ka nang wala munang n, no? X squared muna. Okay? And then, magkakaroon ka ng derivation or assignment. I-assign natin si y kay f. So, ang function ni f, ni x ay magiging y. So, f of y is equal to y to the n power. After so many derivation, yan. Tsaka mo pa lang siya makikita sa huli, no? yung ating final formula which is the same, no? So makikita mo ilang step yung pagdadaanan mo, no? Kung walang chain rule. So in our example, using the chain rule was more difficult than differentiating directly because we already knew how to differentiate x to the 2n power, no? So kung alam mo na daw, hindi mo makukumpara, no, kung sino yung mas madali. Pero kung hindi mo alam, okay, you will say or you will find out na mas madali si chain rule. But we will shortly encounter examples of new functions that we do not know how to differentiate directly. So, next nito is mga bagong function, yung mga various function naman, ang gagamitan natin ng integral at differentiation formula, no? Para makuha yung kanilang derivation. So, remembering the chain rule, ito yon. Ito naman, yung kasunod is, paano daw natin patutunayan na tama itong ating result, no? df of y is over dx. So, ang tawag doon is partial proof. The proof of the chain rule is closely related to the cancellation, but a partial proof of the rule proceeds as follows. So, ito daw yung pinakang proof, but meron pa tayong tinatawag na partial proof para mapatunayan na tama yung ating derivation. So para patunayan yon, alamin natin kung saan siya galing, no? So galing ito kay f of y of x. Yan. Ibig sabihin niyan, y of x, nasa loob siya ng function ni f. So this is a function inside a function, no? Kasi si f ay function at ang function niya may laman na function y, which is ang laman ng function ni y is x, no? So f of y of x ang basa dyan. Okay? So, galing siya doon. After so many derivation, makikita nyo dyan, okay, ay mag-arrive tayo sa simplest formula nito. Yan, which is the same sa taas. Yan. Okay? Hindi pa lang siya nakakancel out. So, this rule works as long as the derivative df and dy over dx are meaningful. Integration formulas, yan, we will find out the integral formula for xn. O, kanina pala yun, no, sa taas. But now we will, derivative pala yun, yung hinahanap natin. How about yung kanyang integration? Okay? So knowing that integration and thus differentiation, we can now use the equation. Ito yung, remember, no? Ito yung kaninang na-arrive natin, no, na derivation. Okay, pabalik naman tayo. Kasi si integration ay kabaliktaran ni differentiation. Okay? So to integrate xn, let's go back to our calculation of distance. Xt traveled by an object moving in the x direction at the velocity of vx. So we will use the following formula, no, ng ating integral, no, integration. So summarizing this or simplifying this, we will have the following formula, no? dx over t over dt. Suppose xt had this special form. So ito na yung form natin. Ibig sabihin, kung si xt raw ay equal kay t to the n plus 1 power, then we will have the following derivation. No? Yan. So cancel out, then it will remain. It will give us the n plus 1 over n plus 1 times t to the n power. And then substituting, we will have this. We will arrive at this, and next we will arrive at the final integral formula of x to the n power. Okay? So ito yon. Tingnan natin. So this is the general stated without proof. Back in, yung previous discussion natin, na-discuss na natin yung integration, no? Wala pa daw proof yun. Pero ngayon, this is the proof, no, ng integral formula for the xn. Derivative or derivative of the exponential function, yun yung ex. So we will use the series expansion for the function ex, no? So remember, integral at derivative ang hinahanap natin. So ito yung ating series expansion. Ibig sabihin yan, si A equal kay 0.01. Kung yun ang starting point niya, then, or starting value, then sa kasunod, we have the following values, no? Ni A squared, the A cubed, okay? And also, the A squared over 2. Yan. Giving us the approximate value of 1.01. Okay? And then, the 0.01, pag prines mo rin sa calculator using the X button, will give you the same exact result. So let's see how to use the series 1364, calculating the derivative of EX. So we have the following derivative. Okay, following the rule of the exponents, no, when multiplying, and also substituting EX, no, on the as the numerator, no, numerator of our derivative formula, then we will have the following derivation. Okay, dx over dx equals EX. Paano naman daw kung may constant? Ayan, constant. Ganun din, no? I-insert mo lang. Lagyan mo lang ng A doon. So, EAX. And you will have si Y magiging AX. Then, you will have the following derivation. EAX is equal to AE to the AX power. And to calculate for the integral of EAX, yan, using the integral formula, substituting, eliminating, simplifying, then we will have the following formula, no? Hindi ko na in-explain yung parts, no? Kasi na-discuss na natin yan. Lagi natin ginawa yan sa midterm, sa prelim, no? Yung substitution, cancellation, cancel out. Yan. So we will have the following formula for the integral, no, ng EAX. And that's it for our midterm part 2 lesson.